Adrastea, Moon, from Wikipedia, the free encyclopedia, at en.wikipedia.org. Adrastea, also known as Jupiter 15, is the second by distance and the smallest of the four inner moons of Jupiter. It was discovered in photographs taken by Voyager 2 in 1979, making it the first natural satellite to be discovered from images taken by an interplanetary spacecraft rather than through a telescope. It was officially named after the mythological Adrastea, foster mother of the Greek god Zeus, the equivalent of the Roman god Jupiter. Adrastea is one of the few moons in the solar system known to orbit its planet in less than the length of that planet's day. It orbits at the edge of Jupiter's main ring and is thought to be the main contributor of material to the rings of Jupiter. Despite observations made in the 1990s by the Galileo spacecraft, very little is known about the moon's physical characteristics other than its size and the fact that it is tidally locked to Jupiter. Section 1. Discovery and Observations. Adrastea was discovered by David C. Jewett and G. Edward Danielson in Voyager 2 probe photographs taken on July 8, 1979, and received the designation S/1979J1. Although it appeared only as a dot, it was the first moon to be discovered by an interplanetary spacecraft. Soon after its discovery, two other of the inner moons of Jupiter, Thebe and Metis, were observed in the images taken a few months earlier by Voyager 1. The Galileo spacecraft was able to determine the moon's shape in 1998, but the images remain poor. In 1983, Adrastea was officially named after the Greek nymph Adrastea, the daughter of Zeus and his lover Ananke. Although the Juno orbiter, which arrived at Jupiter in 2016, has a camera called JunoCam, it is almost entirely focused on observations of Jupiter itself. However, if all goes well, should be able to capture some limited images of the Jupiter moons Metis and Adrastea. Section 2. Physical Characteristics. Adrastea has an irregular shape and measures 20 by 16 by 14 kilometers across. A surface area estimate would be between 840 and 1,600 kilometers squared. This makes it the smallest of the four inner moons. The bulk, composition, and mass of Adrastea are not known, but assuming that its mean density is like that of Amalthea, around 0.86 grams per centimeter cubed, its mass can be estimated at about 2 times 10 to the 15th power kilograms. Amalthea's density implies that the moon is composed of water ice with a porosity of 10 to 15%, and Adrastea may be similar. No surface details of Adrastea are known, due to the low resolution of available images. Section 2. Orbit. Adrastea is the smallest and second closest member of the inner Jovian satellite family. It orbits Jupiter at a radius of about 129,000 kilometers, at the exterior edge of the planet's main ring. Adrastea is one of only 3 moons in the solar system known to orbit its planet in less than the length of that planet's day, the other 2 being Jupiter's innermost moon Metis and Mars's moon Phobos. The orbit has very small eccentricity and inclination, around 0.0015 and 0.03 degrees respectively. Inclination is relative to the equator of Jupiter. Due to tidal locking, Adrastea rotates synchronously with its orbital period, keeping one face always looking toward the planet. Its long axis is aligned towards Jupiter, this being the lowest energy configuration. Due to tidal locking, the orbit of Adrastea lies inside Jupiter's synchronous orbit radius, as does Metis's. The orbit of Adrastea lies inside Jupiter's synchronous orbit radius, and as a result, tidal forces are slowly causing its orbit to decay so that it will one day impact Jupiter. If its density is similar to Amalthea's, then its orbit would actually lie within the fluid Roche limit. However, since it is not breaking up, it must still lie outside its rigid Roche limit. Adrastea is the second fastest moving of Jupiter's moons, with an orbital speed of 31.378 kilometers per second. Section 3. Relationship with Jupiter's rings. Adrastea is the largest contributor to material in Jupiter's rings. This appears to consist primarily of material that is ejected from the surfaces of Jupiter's 4 small inner satellites by meteorite impacts. It is easy for the impact ejecta to be lost from these satellites into space. This is due to the satellites' low density and their surfaces lying close to the edge of their Roche spheres. It seems that Adrastea is the most copious source of this ring material, as evidenced by the densest ring, the main ring, being located at and within Adrastea's orbit. More precisely, the orbit of Adrastea lies near the outer edge of Jupiter's main ring. The exact extent of visible ring material depends on the phase angle of the images. In forward scattered light, Adrastea is firmly outside the main ring, but in back scattered light, which reveals much bigger particles, there appears to also be a narrow ringlet outside Adrastea's orbit. In forward scattered light, Adrastea is firmly outside the main ring, but in back scattered light, which reveals much bigger particles, there appears to also be a narrow ringlet outside Adrastea's orbit. This sound file and all text in the article are licensed under the Creative Commons Attribution Sharealike 3.0 Unported License. Available at creativecommons.org/licenses/by-SA/3.0.